Okay, everyone's ready, we'll get started. So, the plan for today is to just keep moving forward with our understanding of the processing framework, okay? We're going to look at variables and we're going to look at conditions in processing today. And I'm going to show you how to add interactivity to your processing sketches. And if we get time, we'll do an introduction to loops as well. Just hopefully a lot of this stuff you'll remember from first year. You'll remember having done this in C, and you'll just be able to see how it's used in processing, okay? So, if you guys can remember what we talked about last week, can you remember the processing drawing commands that we learned? Line. Yeah. Yeah. What other ones? Yeah. How do we change colors? Background, stroke, and fill. Alright, and just for a quick bit of revision, if I was to use the background statement and then do some drawing before the background statement, what would happen? Exactly, the background statement will wipe the screen with whatever color you specify. How many parameters does the stroke statement take? 3. Either 3 or 1 parameter. So if you've got 3, it indicates the RGB, and 1 indicates grayscale. Excellent. Okay, so that's the stuff we did last week. So, variables in processing. Okay, variables in processing, that's the first question I would usually ask if I had to program something in a language I was unfamiliar with. What are the data types? So can you guys tell me what are the data types in the C language? And we'll just see how they map onto the processing as well. So we have ints. What else have we got? Char, yeah. So is there Boolean in C? No, but there's one in C++. Okay, so if you're using a C++ compiler to compile C programs, you can use Boolean. Okay. In processing, Boolean is written as B-O-O-L-E-A-N. In Java, oh, hang on. No, this is Java. In C# it's written as bool, and in C++ it's written as bool. But in Java, I'm processing Boolean. So we've got int, float, char, Boolean. Short. Short. Yeah. Double. Cool. That pretty much covers it, doesn't it? What about pointers? Do you remember pointers? Okay, so we've no pointers. So we'll just move on from that. There are no pointers in Java or processing. Okay, what's an int? Yes. What's data does it store? What types of data does it store? So it's numbers, whole numbers. Alright. Float. They're the real numbers, basically. Why are they called float? Huh? Floating point. Why are they called floating points? What's the significance of float? Are they lighter than water? Do they float? Why are they called float? Huh? Yeah, but why?
Because that point is going to be in different places.
Yeah, that's it. Okay, so when you look at how it's stored, right, one of the ways, we'll do this at a later stage, we'll look at how floats are actually stored, right? The actual decimal point can float around in the binary sequence of 32 bits that's used to store it. That's why it's called a float. What about a char? Character. How big is a character? Okay, in C it's typically 8-bit. In this language, it's at least, actually I don't know how big a char is. We'll have to do size off, right? But they're at the very minimum 16 bits, right? Why 16 bits? There's only A, B, C, D, F, G, up as far as... Why would you need more? Okay. Uppercase, lowercase. But why do you need so many? Why would you need 16 bits? That's 2 to the power of 16 possible combinations of characters. Why do you need so many for a char? You actually only need 7. But why would you bother? What's the point of having 16-bit characters? What's that? Yeah, why? Why 16? Why not 8? Anyone have a guess? Huh? Locales, exactly. Right, so characters, and this is a term you might hear used in computer science a lot. Computers use, or most computers nowadays in modern languages use a format called Unicode. Have you heard of Unicode? What's Unicode?
Multiple alphabets.
Unicode is the international standard for characters. And there's a number basically corresponding to every character in every alphabet in the world. So, for example, the Cyrillic alphabet, the Chinese alphabet, the Korean alphabet, even O, the system from Celtic writing. There's Unicode characters for that as well. So that's why computers use Unicode. It's for international characters. Okay. So Unicode is what's called a subset of the ASCII language, and that's one of the first important differences between Java and C, and that's that Java from the start is still for internationalization, and so all characters can store any character.
Wouldn't it be the other way around? ASCII being a subset of
Unicode is a superset of ASCII, correct, yeah. So, alright, so that's a character. Boolean. What can we store in Boolean? Yep, either true or false. And those are constants as well. So if I go Boolean B, I can go Bool B equals true, or Bool B equals false. So those words, true and false, have you come across those? Did you do kind of Boolean types in C? What would you have used in C? You could have used 1 and 0, and you could have also used the constants true and false, which are hash defined to be ones and zeros. But in the processing, they're actually there. Okay, what about shorts? Yep, so they're short integers, okay? Another way of, I think maybe a short is a 16-bit integer. It's not too important. What about a long? It's double the size. So how many bytes for a long? How many bytes for an int? 4 bytes, and a long is 8 bytes. It's twice the size. So you can have really, really huge numbers stored in a long. And a double, how many bytes? How many bytes for a float? 4 bytes. So a float takes up the same amount of space as an int. A double takes up 8 bytes, so it's twice the size. And you can store really, really big numbers, or really, really tiny numbers. Numbers with a huge, big, or a really small, what's the word? A very big negative exponent. So something like 0.00000001 can be stored in a double with precision. Okay, so they're the data types. What can we do with data types? I'm sure, hopefully this is all revision for you, but if I have something like int I in my processing sketch, what can I do with that? What's the first thing you can do with that? You can assign it, right? So you go I is assigned the value 0 like that. If I had something like this, float f, could you just do this? Can you do that in C? Yeah. No problem. Why can you not do it in processing in Java, do you think? So you guys should take notes. Whenever I say something significant, it's potentially an exam question or something that you might get asked in an interview. Why is that not allowed in? Well, we can just try and run it and see what happens. Actually, it is allowed. Okay, well, what's going to happen there? Yeah, f is just going to take the value of I. I thought that was going to not comply. But anyway, never mind. Okay, so that's an assignment. Let's just look at the basic operations you can do on an int. I'm sure you know all of this, right? If I want to add something to I, how do I add something to it? So I equals I plus, I equals I plus something. So you go I equals I plus 10. Okay? So that takes the old value of I, adds 10 to it, and then puts a new value into I. So, okay? So I'll revision, I hope. Okay. Another way of writing that is I plus equals to 10. So those two statements mean the same thing, don't they? Everybody happy that if you see I plus equals to, that just means the same as I equals I plus? Alright, have you come across that before? Yeah. Alright, is this very boring and revisiony? Good. Okay, glad to hear that. That's awesome. If you just want to increment or decrement I, you can go I plus plus. You can also go plus plus I. What's the difference between those?
The increment for 4i is plus I.
Yeah, so one is called, what's the first one called? Post increment. And the second one is called?
Pre-increment.
Okay, so let me ask you a question then, right? If I do something like this. Okay, what's the value of j going to be in that statement? If this is all revision, you should know this. I'm sure it is all revision, but just work it out. Do it step by step. Answers? 10. Any other suggestions? 20? 21? 11? 10. Now, how many people really think it's those things? Put up your hand if you think it's 10.
It's just the I plus 10. If the other two are still at 20.
Well, there's the program. You tell me. It's on the screen. So how many people think it's 10? How many people think it's 20? 1, 2, 3, 4, 5 people. How many people think it's 21? Okay, a few more people. Let's say maybe 15 people. How many people think it's something else? What do you think it is? 22. 22. How many other people think it's 22? Let's work it out. We should be able to work it out. And by the way, everybody at this stage, we would hope that everyone would come to an agreement and know this just straight off. Okay? When you look at a program like that, a very simple program, everyone should know straight away what the answer is. So we'll take a look at it, right? So I starts out at 0, I equals I plus 10. So I now takes the value of 10. And then I go I plus equals to 10. So then I becomes the value 20 at that statement there. Actually, you know what? I'll write it up here. So I equals I plus 10. So at this stage, I is going to be equals to 10. At this line here, I is going to be equals to 20. Now this line here is the tricky one, because what happens, I add 1 to I, don't I? But before I add 1 to I do the assignment. And that's the difference between pre-increment and post-increment. It's when the assignment happens. And because I'm doing post-increment here, the assignment happens and then the increment happens. Everybody understand that? So what happens here? J is going to take the value of I, which is going to be 20, and then I'm going to add 1 to I. So that means I is going to become 21, and J is going to be equal to 20. And then at this stage I add another 1 to I, so I is now going to take the value of, I is now at this stage is going to be equal to 22. Alrighty, that's what's going to happen there. Does everybody understand post-increment and pre-increment? I'll just change this program around very slightly, okay? So let's now just say I is equals to 20. And then let's write this statement instead. J equals plus I. What's going to happen there? So after this, I is going to have the value of 21 and J is going to have the value of... How many people think J is going to be 20? How many people think J is going to be 21? How many people think J is going to be some other number? How many people didn't put up their hands? If you don't put up your hands, you're off the course. You have to always put up your hands and say something, even if it's wrong. Have a theory. Okay? It doesn't matter if it's the wrong theory. So the answer here is J is going to be 21. Because what happens here is the increment operation happens first and then the assignment happens. That's how you disambiguate between pre-increment and post-increment. Is that okay with everybody? Alright, so a lot of these things work equally but multiplied by as well. Obviously pre-increment and post-increment don't work. But you can also go J equals J multiplied by 10. Or you can go J multiplied by equals to 10. So all those statements work as well. And then, oops, not that one. And then to do division, you can do J divided by equals to 2. And then J equals J divided by 2. So those last two statements mean the same thing. So quick one then. What's going to be the final value for J in that sequence? And if you need to, work it out on paper. Okay? 50? I need advance on 50. 525. Okay, maybe. 550. And I can't emphasize how important it is that you don't kind of leave the room without understanding this at a deep level. This is really the fundamental stuff that it's just very, very important to understand this. Okay? So if you have any questions, then ask me the questions. If you're not too sure why something is whatever. But certainly after I explain this to you, if you still don't understand, then ask a question. Right? Okay. How many people think the answer is 525? How many people think the answer is 550? Okay, so we've got 2, 3. How many people think it's something else? What do you think it is?
1050.
1050. Did you just run that program?
No.
Good. 1050. Alright, let's work it out. So first of all, I equals 20, j equals plus I. So what's the value of j going to be after that? Very important. What's the value of j? Look again. Oh yeah, it is 21. J is going to be equals to 21. Why 21 and not 20? Because it's pre-increment. It does the increment first and then we'll do the assignment. So J is going to be equals to 20. I is going to be equals to, J is going to be equals to 21. I is going to be equals to 21 as well. Okay, because the increment happens first and then the assignment happens. Then I go J equals J multiplied by 10. So we'll take 21 and multiply by 10. So now J is going to be equals to 210. Is that okay with everybody? And then here I go J multiplied by equals to 10 as well. So J now is going to become 2,100 multiplied by 10. So J now takes the value of 2,100. Then J divided by equals to 2. So that takes the value of J and divides it by 2. So now it's going to be equals to 550. Oh, sorry, 1,050. Correct? Is that right? Okay. And then I divide by 2 again, so now I get 525. Okay, be honest now. How many people said 525? Those of you that thought it was something different, can you see why it's 525? Is there any ambiguity between what any of those statements are doing up there?
No, I just missed the last
You just missed one of the calculations, did you? No problem at all. Okay, cool. I don't care whether you get their answer right, but I want everybody to have a theory. I want everyone to have a hypothesis and be able to see how the sequence of operations happens. Is that okay with everybody? So they're the basic operations we can do on ints. There's a few things we can do on bools. Boolean B. So I can do straightforward assignment. B equals true. And that will check the value of B. If I want to assign B from a calculation, you can go B equals... Okay, so we reckon J was 525, right? So can you write this? So if you write that statement there, what's the value of B going to be? It will be true. Okay? So this is a thing that isn't really in C, but actually it is in C. You can do this sort of thing in C as well. But it will assign the values of 0 and 1 as opposed to true and false, right? So B equals J equals 252. So that will do is evaluate that bit inside the brackets. Remember we were talking about brackets last week. That's brackets for precedence. It will do that bit in there and then do the assignment to B. So it will evaluate that. And if that evaluates the true, B will take the value of true. We can also do something like this, can't we?
How big is
Boolean is actually 4 bytes. Even though technically it doesn't need to be 4 bytes. I'm not exactly sure why it's 4 bytes.
Yeah, does it need 1 bit?
It does need 1 bit, but all computers are what are called byte addressables. The smallest bit of addressable memory is a byte. That's the smallest anything can be.
Okay, so...
You know what? If anyone has the internet open there, will you just Google it? How big is a Boolean in Java?
I think it's 1 bit, isn't it?
It's not 1 bit. It couldn't be 1 bit because computers are byte addressable, which means the smallest it could possibly be is a byte. You know how memory addresses work? I'm sure you did this with Michael and C. You know, when you've got a pointer, it's a 32-bit number which is telling you the location of something in the computer's memory. And that 32-bit number is the location of a single byte. So 8 bits is stored in that 32-bit number, or at the location pointed to by the So anyone, any answers? What's that?
Virtual machine independent.
Okay. Does it really say that?
Says it here.
Wow. Okay. Let's not worry too much about it, right? Anyway, J is equals to 525 or J greater than 10. 1 bit.
It's on the Oracle side, so
What's that?
one bit on the Oracle side, but it's also between them.
Oh, okay. So, okay, maybe they pack them. Maybe they can pack them into 8 bits, which is also possible, but I didn't know the virtual machine did that. Not to worry, right? Anyway, so what are those two symbols there, those two lines? What are they called? Yeah, so it means or. But what do we call them in computers? The actual symbol? It's called a pipe. Alright, that symbol there is called a pipe. Or J is equals to 10. Okay, so we can also do something like this. What does that mean?
Not B.
Yeah, so that symbol there, what do we call it? We read that as B equals not B. And what will that do? How is it possible for B to be equal to not B? In a way, when you read that, it makes no sense, because that it means, you know, well, I'll tell you what, because that means we're reading the statement wrong. What does that actually mean? If I read that correctly as a programmer, what does that mean? B, yeah, it's not equals to. Equals to is how we understand it, you know, B is assigned the value of. Alright, so when you see a single equals, it means an assignment rather than equals, which is, in order to do equals, we put two equal symbols like that, okay? So that means B is assigned the value of not B. So if B is true, it becomes false. If B is false, it will become true. So this is how I solved that thing last week of the flipping between the happy and the sad faces. Alrighty. So there are things we can do with Booleans. And things we can do with floats are pretty much the same things we can do with ints. But it is worth just mentioning floats. Do these two statements mean the same thing? And have you ever come across the second way of doing an assignment to a float? Have you seen the second way before? So if you were doing an assignment to a float in Michael's class, you just would have written it as f equals 0, would you? Okay. Can anyone tell me, is there any difference between the two ways of doing that assignment to a float? And maybe if you think about it a little bit, have you seen that 0.0f notation or way of writing floats before?
Is it how many decimal points after the 0?
Not exactly, right? But it's more to do with the data types. What am I doing in the first one? I'm assigning what to be what? I'm assigning an integer to be a float. So what will actually happen here is it has to convert from an integer to a float. Because on the right-hand side of that statement is an integer. 0 is an integer constant. So it'll have to take that integer constant and convert it to a float constant. Or convert it to a float. In the second one, what's the thing on the right-hand side? It's already a float. That's a float constant. So when we do assignments to floats, from now on, whenever you're writing programs, write it in the second format. And that's really the standard that programmers like to take for assignments. So this is assignment. That's an assignment to is constant. Okay, there's one other data type in Java which isn't in the C programming language, and that's called the string data type. So a string is written like this, S-T-R-I-N-G. So we use uppercase S, as opposed to all the other ones are lowercase. And string in Java is built into the language. And, you know, strings are just something that all programs need to deal with. So Java's put a specific thing in there for dealing with strings. And we'll probably have a class or two on some of the things you can do with strings. But just to show you now, if you want to print something out, you can go string S. And that's a sequence of characters. Strings in Java and processing are always constant and immutable. They can never change. You can allocate a string, you can give it an assignment, and then when you assign that string to another value, it will throw away the old string and do an assignment to a new one. So you could go S equals, and then assignment to a string, you use the double quotes like that. Okay, so that's how you do a string assignment. Or I could do something like this, S plus equals to. So after I do that, what do you think the new value for S is going to be? It will be hello world Brian. So what's happening there? Yeah, and when we call that, when we add two strings together, what do we call that? Concatenation. So this is concatenating two string constants together. Another interesting thing there. What if I was to read that in the same way as I read the other, the stuff we do in ints and floats? What's different about that?
There's no decrement or...
There's no decrement. Exactly. Well, I mean, even just looking at it straight away, you can see that is changing the behavior, changing the meaning of what plus means. So plus for strings means something different to plus for integers and floats. Plus for strings means append or concatenate the two strings. Plus for integers and floats means just add them. Okay, so that means a different thing. Some languages like C# and C++ allow you to change the behavior of the operations, and that's how it's implemented. But in Java, it's just built into the language. That plus always means concatenate two strings. Yeah.
If you're doing a minus, would it start taking away the front of that?
It actually won't compile. There's no way you can't do that. Because number one, the string is immutable. Once you've created the string, of course you can create a new string with a subset of the previous characters from the previous string. But it's a new string, and you can't as such just remove a character from the string. Yeah.
If you remove that space in the first one, hello world, would it put this in for you, or would it?
No, you have to put the space in. Yeah. Because it doesn't know anything about English or any other language, or it doesn't know that there needs to be spaces, so you have to put the space in. Okay, so that's the basic data types of processing. Okay? So I'm going to save this sketch, and I'll put it up on the repository with some notes for you guys. Oh, sorry, one last thing I'll just show you very quickly. It's not going to take too long. Just something that you can do. Remember we had this discussion earlier about what's the value of j? Let's test that. And to print stuff in processing is really easy. It's actually just print ln. And then you can just say, what do you want to print? There's no format specifiers like you would have had in C. You would have had, what would that have looked like in C? Printf, double quotes, percentage. Percentage f, double quotes, and then comma the variable name. In processing, you just go j, and you can do stuff like this. So I can append these two strings on the fly. So I can go like that, and it will just append those two strings, concatenate the two of them together. Which is, yeah, it doesn't matter. It will convert it to a string automatically. So yeah, we don't need to worry about that. It will concatenate them. Yeah. What would happen if I wanted to do this the other way around? Just a quick kind of gotcha. Alright, both of those statements look pretty much similar. The value of j is, and then it's going to do the j thing, and j is the value of j. Alright, so they're obviously we're trying to do the same thing more or less in both statements. The first one will compile, the second one won't compile. Any idea why the second one won't compile? Yeah, why does it have to be after? That's exactly right.
You need to declare j, because no one j after, and what j is.
Well, we've told j, we're happy with j. J's a float, so that shouldn't be a problem for us. Yeah.
Does print ln convert everything to string and then prints?
Print ln expects everything to be a string, right? So what's actually going to happen here is, and it's kind of a weird thing, can anyone figure out why the second one won't compile? What does plus mean? Yeah.
Because it opens with the j value, the variable.
Exactly, but why is that a problem?
Are you sure that?
Yeah. I'm 90% sure. But just to be on the safe side, let's do it. Oh, okay, so that's something. It does compile. And it works correct. You may have to reevaluate. Okay, I'm going back. Okay, I'm waiting. Somebody else teach this class. Yeah, I didn't think it was going to compile. It did compile. The reason why it slightly annoys me that it compiles is because when I'm doing j plus, j is a float. So I would have thought what it would try and do here is convert this to a float and then add two floats.
Try doing like integers. Maybe just takes everything
No,
as
I'd
string.
say that j is an integer, isn't it?
No, maybe just takes everything as strings.
I thought that second one wasn't going to compile. Anyway, it doesn't matter. Okay. It's not the purpose of today's class. But an interesting, we've all learned something today, haven't we?
Yes.
Yes. Good. That's the most important thing. All right. So we've got strings, floats, booleans, and stuff. Right. Let's do something cool with processing, and then I'll get you guys to work on something. I'm going to save this. I'm going to call this variable data types. And I'm going to create a new processing sketch. And I'll get it to do some drawing. Okay. Let's see. What's the first thing? Oh yeah. Okay. You guys know that all of those statements are to do with modifying the values of variables, but you can also like kind of temporarily use a variable without modifying its value, but at the same time changing the value. So for example, you can do something like, which I'm sure, let me just show you for this one. You can also do something like this, j equals I plus 10. Can't you do that? Now looking at that statement there, does I change its value? Does j change its value? Yeah, so we've got an assignment to j, but it just takes the old value of I, adds 10 to it, temporarily, and then stores that in j. Is that okay with everybody? So we can mess around with variables like that without modifying their values. Right, let's try a little processing sketch, right? First thing I want to show you is this, right? From now on, we're going to change the way we write these processing sketches, right? There are different modes in processing, and we're going to use this mode, which allows us to separate our sketch into different blocks. One bit which gets executed right at the start of the processing sketch, and another bit which gets executed every frame. Exactly. You know how animation works, don't you? So if you consider like a Disney cartoon, and if you can separate out the frames, somebody running, there might be one frame of the person looking like this. Probably not, just like that. And then you get the next frame, and it will be slightly, they will have moved a little bit, like that. And then when you string them all together and play them back at high speed, it looks like the person is running. Okay, you've seen that? Okay, the processing is no different. Processing will update your sketch 60 times a second, so that you can see, you know, animations and things happening. Let's try something here, okay? First of all, this is the setup bit. What's that? What is that in programming? Sure thing, but what is it? What is that thing? It's a method. Okay, so we'll call them methods from now on. They're what we would have called functions in the C programming language, right? So void setup, it means when you put void in front of that method, it means it doesn't return anything. Does it take parameters? No, and it begins and ends at the open curly bracket and closes at the closed curly bracket, right? This is the bit of the processing sketch which runs once per frame, okay? So what sort of stuff should go into setup? Size would be probably one thing that pretty much, I don't need to change the screen, just want to change it once to be that size, and then I don't need to do that each frame. So then let's just put a very simple call in here. Let me put ellipse in the center of the screen. How do I figure out what's the center of the screen? Okay, so there's lots of built-in variables in processing, which we'll go through, which is today. Number one built-in variable is width and height, which basically tell you the width of the screen and the height of the screen. So, divided by 2. So I can do something at cent x, comma, cent y, and then the width and the height, let's do 100, comma, 100. Yeah, cool. Let's try it. Let's run it, see what happens. Oh, look at that. A circle. How amazing. Let's change our processing sketch very slightly, okay? We'll use one of the built-in variables here. There are a couple of built-in variables in processing. Number one is mouse x, and the other one is mouse y. Have a guess at what you think they are and what type they are. Mouse x and mouse y.
What are the positions?
They are the position where the mouse is currently. In terms of the window, they'll give you the relative position. So 0, 0 is the top left of the window, and then the width of the height is going to be the width of the height of the window. Okay, let's do something with variables. Let's try this here for the hell of it. Yay! This is so exciting because it's actually going to do something interactive now. Sketch is going to be doing something based on where the mouse is on the screen. Can you see that? So what's the mouse X and Y controlling? It's controlling the width and the height of the ellipse. So what do you think is going to happen before we even run it? Yeah, okay, let's try it.
How do you make it clear to change?
Good question. I need an answer to that. How do we get it to wipe the screen?
Draw the you could put the background inside the draw
Yeah, got it.
and
Perfect. That's all we need to do. So, thinking about it, if I put the background code up here, it'll only do it once, won't it? What should I specify for the background? If I want it to be black, 0. Background 0 will make it black. And then say I want white. Stroke 255 will make it white drawing. And let's do fill of 0 as well. So we get fill 0 and then this isn't going to modify things really too significantly. Now, because the background column is up at the very top, you know, it's in the setup code, it means it's only going to execute once. Of course, if I take that background code and I move it down to here, then I'm going to get my little interactive circle, which is going to grow and shrink depending on the mouse position. So do you understand what, I mean, I hope this example shows you that, you know, hopefully you can understand what a variable is. A variable is something which has got the capability to change its value, and its value is going to constantly hold wherever the mouse X, or wherever the mouse X and Y is on the screen. Right? Let's try something else. Let's do this. Do stroke and fill. Right, what's going to happen now? Got it. We'll take the color from where the mouse is on the screen. And don't forget, these should go between 0 and 255, but we can go beyond the bounds. The program will still work. I can't quite remember what it does. Does it clamp it? Or does it wrap it or something? I can't quite remember. Anyway, we can just try it. So yeah, now I get different shades of this kind of purple thing depending on where I am looking at the screen. And let's change it around just even more. Let's go. So I'm just using the mouse X and Y to control different parameters of fill. There we go. Impressed? Okay, time for your first task, okay? Your first task is this. I want you to write a little processing sketch, and you can use this as a foundation, right? What I want to happen in this processing sketch is I want you to draw the circle. I want the circle to start here on the screen, and then I want the circle to move over to this side of the screen. So in other words, I want you to animate the circle so that it moves from left to right. You follow? Think about how you're going to do that, okay? And you can work in groups to do it, and it should only take you a couple of minutes to figure it out. Can you try that? Okay, I'm going to do the solution because I want to move on a little bit, okay? Let's get rid of all this stuff because this is just some kind of example stuff. So basically, you can see that the position of the ellipse here is being controlled by a variable which is the mouse X and Y. Instead of using that, I can just go int X here, and I can maybe just do my assignment there. And then use X there, and then go X plus X. Which will just add 1 to X each time around I do the draw. So let's try this one now. And there's the thing moving all by itself. So just before I move on, will everybody please just take a minute to take a look at this program and make sure you understand. You know, if I simplify this, I'll get rid of all this stuff here, right? I'll leave those because they're kind of cool. So say instead of using mouse Y, I use 100. And instead of using mouse X, I'm going to use maybe 100 and 100. So my circle's always the same size. What we're basically doing here is we take the initial value of X, which is 0. The very first time inside the draw loop, it will use 0. And then it's going to add 1 to X, so that the next time we come into the draw loop, X is now going to be 1. Yeah.
Is that an int x? Is that global?
Yes, it is global.
And is there any way around that?
When you say
Like we were told not to use global variables.
sure. No, there's no way. I mean, there's a use for, a variable in this situation. There's very much a use for. Eventually, we'll get to make classes and things. We represent things using classes, but still, this is, processing is important, and you have to use globals. You have to have the variable declared outside the draw function, because otherwise, if I just declare it in the draw function, it will get allocated and deallocated. Okay, now, sorry, just before we move on, does everybody 100% understand why the circle moves?
Yeah.
Yeah.
If you're getting one in the frame, you're getting the background of the circle and the background of the circle.
Exactly, and you can see that each time around in the frame I'm adding 1 to X. Yeah. Excellent, even better. That's the next step, right? Let's think about this, right? The next thing I want you guys to think about how to do is get it to move to the extreme right of the screen, and then once it reaches the extreme right of the screen, it has to kind of bounce, if you like, and start moving off to the left again, and once it reaches to the left, it's going to go moving to the right, and so on. So it's going to oscillate from left to right across the screen. Do you know what I'm talking about? Yep. What's your name again? Darren. Darren, will you lift up your laptop and show everybody, please? Can you see that? That's what I want you guys to do. Get it to move to the extreme right of the screen, then it's going to bounce and go back left and right, left and right, oscillate back and forth. And in order to implement this, what bit of programming are we going to use? We're going to use the which statement, which thing are we going to use? We can use a bool. But what's the most important thing? Okay, I'll let you think about it, right? There's the most important thing in programming. Well, in this particular thing, we need to figure out. Okay, just take maybe 10 minutes to do that, then we'll take a short break. Okay, if everyone could just be quiet for a sec, right? I'll just go through the solution to this. First, if we kind of divide this up into two problems. The first problem is I want to draw those lines. These vertical lines and then these horizontal lines here. And what I'll try and do when I'm writing this is I'll try and do it in a way that it's independent of what the screen size is. So my screen size here is 500 pixels wide. So this is going to be 250 pixels. So I could just draw a line over 250 pixels at 0 and then 500, over 250 pixels and down 500 pixels, and that's going to draw that line. But a better way to think about it would be maybe to use a variable and calculate what half the width is and half the height is, so that it will work regardless of what the screen size is. So that's the first thing. The second part of this then is figuring out what quadrant your mouse is in, and there's probably a nice solution to this, a nicer solution, but the simplest solution is basically just to write 4 if statements. Okay? So if I take my x coordinate here, my mouse x and mouse y, if I'm in this top coordinate, I need to be less than half the width and less than half the height for my y. For this one here, I need to be greater than the width and less than half the height. And for this one, I need to be less than the width, greater than half the height. But for this one, I'm greater than half the width and greater than half the height. The other thing to think about as well is you need to probably use greater than or equals to at some point, because otherwise you'll have dead zones in here. Like if you were exactly on one of these lines, which quadrant would you be in? You just have to make a decision. And then so use greater than or equal to for some of it as well. So that's the two problems. And I'll show you how I came up with this one. So if I look at my processing sketch, first thing, I declare these two variables for cent x and cent y, which are going to store the half the width and half the height. And I calculate those values in setup, so I don't have to calculate them each frame. So then I draw two lines. So this first line, center x and down 0, and center x and then down the height. So that's going to draw that vertical line. So I go half the way over, start at 0, all the way down, but the x value doesn't change. And then for the other one there, I start at 0, down half the height, and then over as far as the width. So that's going to draw those two lines. And then here's my 4 if statements. Just checking mouse X and mouse Y against the 4 quadrants. And for the first one, I'm just going to say it's not inclusive. So if I'm less than half the width and my mouse is less than half the height, then I draw the rectangle in, starting at 0, 0, which is the top left, and then going over center X and center Y, which is half the width and half the height. The next one then I'm checking to see if I'm greater than or equal to the center X. And that avoids having that little dead zone right on the line. And then if I'm also less than half the height, and then I draw that rectangle, and then so on for the other 2 rectangles. And I'll put this, obviously this will go up on the GitHub, you know. So I'll put all the examples we did up on the Git repository, and I'll put a list of the programs with the videos for today as well. And there we go. So I've got 4 if statements like that. You know, the nice thing about doing it like this is if I change this to be 100 and 100, then my sketch will still work. You know, so that's why it's better to use like variables like that rather than hard-coded values. Is that okay with everybody? Anybody want to ask any questions? Do you all love programming and processing? Yeah. Yay! I'm so pleased. Okay. I think we'll kind of wrap up there, okay? It's nearly finished. And don't think there's anything else really we want to do today. Anyone any questions? Okay, I'll give you something cool to do in the lab tomorrow with if statements and variables and processing, okay?
Yeah.